Hi, everyone. Today we're going to talk about three different types of bonding. We're going to talk about ionic, covalent, and metallic. But today, right now, we're going to focus on ionic bonding. As a quick reminder, many things are made of combinations of elements. All right. So we know that elements are located on the periodic table. For example, carbon, nitrogen, oxygen, helium, all of those. And when we have a combination, which means that two or more elements are going to come together, that's called a compound. Sugar, salt, gasoline, and chalk are all compounds. And they are going to have atoms of more than one element joined together. So today I kind of want you to think about how are the compounds alike and how are they different? And that's what we're going to be talking about. Scientists classify or group chemical compounds by the kinds of chemical bonds they have. A chemical bond is basically when atoms are going to join together to form compounds. And so bonding basically happens when we talk about the valence electron. So you guys remember doing those Bohr models, right? So protons and neutrons are in the where? The nucleus, and our electrons are on the outside rings. And so the valence electrons, remember what that is? Think about it. All right, I know you got it. Valence electrons are electrons in the outermost energy level. And so let's say you have an element that has two in the first ring, and then you have two in the next ring. Well, how many valence electrons do you have? Yeah, two, because that's your outermost ring. Awesome. So we're going to talk about ionic bonding. And so ionic bonding is all based on extraction between ions that have opposite charge. So once again, ionic bonding is attraction between ions that have opposite charges. And that is when a metal and a nonmetal are going to combine. So we're going to talk about metals and nonmetals. So in your notes, we're going to write this down. So ionic compounds form strong bonds because of the attraction between opposite charged ions. And this basically occurs, what it looks like is a crystal lattice repeating pattern. So let me rewind for a minute. Ionic compounds are brittle at room temperature. That means they break apart when they're hit. They break because their ions are arranged in this pattern that happens over and over again. And that's what a crystal lattice basically pattern is. So it'd be like A, B, A, B, A, B, A, B, A, B. You get it, right? Repeating. Each ion in the lattice bonds to the ions around it that have the opposite charge. So it's going to be, like I said, A, B. It's not going to be A, B. It's going to be A, B, A, B. So when you basically hit an ionic compound, the ions move and the pattern changes. Ions that have the same charge line up and repel each other. That makes those crystals break. And so I'm going to show you a picture in a minute about what that crystal lattice really looks like with that repeating pattern. But I want to dive into an example. So I'm going to show you some notes and then we're going to talk about it. All right. So as I told you earlier, this is kind of like the mean bond, right? And so this is when you're going to have an element that's going to take another electron from another element. So let's first talk about NaCl, and then it'll all make sense. So let's talk about Na, which is sodium. Can you find that on your periodic table? Great. So that is atomic number 11, right? Right. That's in what group? Did you say 1? Perfect. Yes, it is an alkali metal. Group 1. That means that if you do the Bohr models, just like on the left, you're going to see that it has 2 electrons in the first ring, 8 in the next, and that means you have 10. But we're trying to get to 11. So you have 1 left in the last third ring, which means that's your valence electron. Now let's look over at chlorine. Well, chlorine's atomic number is 17, which means what group is that in? Did you say the halogens in group 17? Great job. All right, so we have to get to 17 electrons have to go in different rings. So 2 are going to go in the first ring, 8 is going to go in the next ring, and that means you have how many left over? 7. All right, so we've got 7 in the last ring. Let me ask you a question. What would be the least amount of work? Should sodium go to chlorine and take 1, 2, 3, 4, 5, 6, 7 electrons? That sounds like a lot of work. Or would chlorine just come here and take that 1 electron? Oh yeah, totally. That's so much easier. Chlorine just has to take 1. And that makes life so much easier because I just have to take 1 little electron. I don't want to have to go and do that 7 times. That sounds like too much work. So chlorine's going to come and steal the 1 from sodium. Dun, dun, dun. And so he stole that 1. Okay. Not a very nice thing to do. Chlorine, that was not a nice choice. Shouldn't steal. But it did. That means that is a negative charge. It was not a nice thing to do. Negative. Okay. Now sodium was just like, oh, well, didn't do anything, didn't react. So because sodium didn't react, that's a positive charge. All right. I'm going to explain it again in a minute, but know that the elements are trying to do the least amount of work. And that means that chlorine stole the 1, and that's not a nice thing to do. That's a negative charge. So let's look at some more of my visuals for y'all. And I'm going to walk through all of this too. All right. So NaCl, we talked about sodium chloride. That's table salt. Okay. So look at this visual. So what this visual is once again, you have your sodium that has 1 valence electron on the outside ring. And then over here, you have your chlorine, which has a total of how many right now? 7. But when they combine, chlorine is just stealing that 1 electron, which means it's a negative charge. And then over here, you have sodium, which has a positive charge. Okay. And so this is a little bit about ionic bonds. As a quick reminder, they are also having high melting points. They don't melt easily. They also are highly soluble, which means that they dissolve easily in water. Water molecules attract each of the ions and pull away from them. So just as a reminder about some properties that ionic compounds have. In addition to that, they also conduct electricity, which means they dissolve in water and form a solution that can conduct electric currents. It conducts electricity because its ions are now free to move completely in an electrical circuit. And when ionic compounds are solid, their ions are not moving freely. So they won't have an electrical current. So I wanted to kind of do a quick reminder of, let's do a summary. Ionic bonds are a bond between a metal and a nonmetal. Remember, metals are located on the left side of the periodic table, and nonmetals are located on the right side of the periodic table. In addition to this, you have your metal. You have to do your Bohr model to figure out how many electrons they have in the outer ring, or you can just look at the group number. So remember, group 1 is going to have 1, group 2 is going to have 2. Transition metals will either have 1 or 2. Then group 3, my 13 will have 3, group 14 will have 4, group 15 will have 5, 16 will have 6. Then you have your 17 will have 7, and 18 does not bond with anybody. Remember that, guys, because they already have a full ring. So you will not find helium bonding. You won't find any of the other ones in that group or family bonding because they have a full electron, or they have already a full electron shell. So we're going to pause